Hey everybody, it's Miss Sawyer. Welcome back to another week of geometry. We are going to do some review today on segment addition postulate. So let's get into some quick examples. This won't be a very long video, but I wanted to show you some more in-depth examples of what you might see when it comes to segment addition. All right, so when we're talking about finding lengths, remember that segment addition says if you have a segment that goes from, let's say, A to C, and point B is someplace in between, that from A to B added together with what you have from B to C will give you the total length from A to C. So if we translate that into what we're looking at here, remember that if this section is 10 and the whole thing is what they're showing you here is 12, and they ask you, what's this missing length? Well, 12 minus 10 would just be 2. Same idea with number 2. They said the length from K to J is 3, and the whole length is 14. How much is this missing segment? Well, 14 minus 3 would leave you with 11. But then they're going to try to complicate things by putting variables in the mix. Not a huge issue. Remember, this section is from C to D. That's 2x. We add that to whatever it is from D to E, and we equal it to what the whole distance is. So always just remember, you're going to add the two smaller sections and make them equal the larger. Sometimes there's more than two small sections, and we'll get to those questions later this morning. So 2x plus x plus 4 equals 22 would be our simple equation to start with. We added the two smaller sections and made them equal the largest piece. Now we need to combine like terms. Well, 2x plus x would give me 3x plus 4 equals 22. How do we solve a problem like this? Well, we subtract 4 on both sides. So we get 3x equals 18, divide both sides by 3, and we end up that x equals 6. Let's do the same idea for a problem like 4. We have the section from D to C is x plus 9. The section from C to B is x plus 8. So let's add those together. X plus 9 plus x plus 8 equals the whole length underneath they showed us was 15. Adding up like terms, x plus x would be 2x. 9 plus 8 would give us 17 equals 15. Bring that down. Minus the 17 on both sides. So we get 2x equals negative 2. Divide both sides by negative 2, and we are left that x equals negative 1. Now, some of the problems we're going to run into are going to involve variables on both the top and the bottom. We can handle these problems the exact same. We're still adding the two smaller portions of the line and making it equal the portion on the bottom. So let's write an equation for this. 7 plus 2x minus 14 equals x plus 5. Well, if I want to combine like terms here, the like terms are 7 and negative 14. Well, 7 minus 14 would be negative 7 plus 2x equals x plus 5. Now I have variables on both sides, so I want to subtract the smaller variable to get rid of it on the right. That will leave me negative 7 plus 2 minus 1 is 1x equals 5. Add the 7 to both sides. So we're left that x equals 12. Now, the hardest part of this problem is they didn't ask us necessarily to find out what x equals. They said find ST, which means taking that 12 and plugging it back in. So if I take that 12 and I plug it back into the portion they asked me for, they said find ST. That's this portion right here. So 2 times 12 minus 14. Well, if we do 2 times 12, that's 24. 24 minus 14 would get me a final answer of 10. So you just got to make sure that you're plugging back in where they've asked you to plug in. Let's take a look at number 6. We have this small section, which is just x. This length is 8, so we have x plus 8 equals, what's on the bottom, is 10x minus 1. Well, in this case, we're actually just solving for x because L to M is represented by x. So all we have to do in this problem is actually solve for x. This one will be fast. So let's subtract the smaller x from both sides. That would leave me with 8 equals 9x minus 1. Add 1 to both sides. We get 9 equals 9x. Divide by 9. And we end up that x equals 1. So this section is 1, that section is 8, and the whole section would be 9. But the problem just asked me to find LM, and LM was represented by x. Now these last couple of problems that we're going to see here are dealing with segments that have more than 2 points on them. The good news is the segment addition postulate still applies. The question here says find F to D. So let's highlight the portion that we're actually looking for. So from F to D, I'm looking for that section of the line. I know from E to D is 8. I know from G to F is 10, but I don't know what goes in that middle spot, which I actually need to figure out. So how can we figure out what goes right here? Well, we kind of cut off this diagram and we ignore the 8 for just a second. If I ignore the 8 for just a moment, if this portion from G to F is 10, and the whole thing from G to E is 21, what would be left in this portion here? If you said 11, you would be correct. So now let's take off what we erased and take a look now. If I want to know what that green section is, well, 11 plus 8, F to D is equal to 19. So you have to use a little bit of process of elimination almost to figure out all the missing pieces and then add up the ones that they've asked you for. So again, I would suggest to highlight the section they're asking you for. Here they want to know from S to V. They actually want the whole distance of the whole line, which means I need both of these smaller pieces. So let's look at what we can figure out here. So we know from T to U is 10, but we don't know what it is from U to V. But the next piece of information they gave me was that from T to V was 21. That means this section again would have to be 11. So that now we have used this portion of information, I would tell you to scratch that out because you're probably not going to need it anymore. Now if we look at, we still have T to U being 10, but this down here told me from S to U was 18. Well, what would that leave for this first portion? If you said 8, you would be correct. So now if I'm asked to add up and get the entire whole portion of this line, everything from S all the way to V, all I would have to do would be to add these three together. 8 plus 10 plus 11 would get me a total of 29. And when you have variables in here, again, nothing different really happens when you have variables involved. Just remember, all the pieces on the top or all the smaller portions of the line, all of these get added together to equal what the entire line is. So if we write an equation for this, 12 plus 11 plus x plus 1 equals 4x plus 3. Oops, sorry, 4 plus 3x. Let's change that, 4 plus 3x. So let's add together some like terms in here. We have 12, 11, and 1 as whole numbers on the left. Well, that would add up to 24 plus x equals 4 plus 3x. Now we're to an equation that most people are comfortable solving. Subtract x from both sides. We're left with 24 equals 4. I keep wanting to put the x there. 4 plus 2x, because 3 minus 1. Subtract the 4 from both sides. So now we're left with 20 equals 2x. Divide both sides by 2, and you're left that x equals 10. Last problem, let's change colors so we don't run into each other. Add them all up on the top. So 6 plus 1 plus 2x minus 10. So 6 plus 1 plus 2x minus 10 equals, what's on the bottom? X plus 6. Let's combine some like terms. So 6 plus 1 would get me 7 plus 2x minus 10 equals x plus 6. You can do it in pieces if you want to. You can do it all at the same time. 7 minus 10 would give me 2x minus 3 if I combine those two terms equals x plus 6. Subtract your smaller x. 2 minus 1 would just leave me with x minus 3 equals 6. Add 3 to both sides, and you're left with x equals 9. So hopefully that gives you a good handle on how to handle your segment addition questions that you might run into today. You've got some practice on Edulastic, and let me know if you have any trouble. Thanks for watching. See you guys tomorrow.